Java and C++ are compiled, statically typed languages with similar syntax but different ways of running code. Java is said to be able to run anywhere, and C++ is able to run into memory leaks faster than you could say public static void main string args, which brings us into how to start a program in Java. Every .java file needs a class declaration, public class name. In these curly brackets is where you put all the code for your class. To actually run the code, you need the aforementioned public static void main string args, which tells the Java virtual machine where to start executing the program. We'll get more into this later. To print in Java, you call the built-in system class, access its out object, and then call the method print. In C++, you start a .cpp file with int main, which shows the compiler where the program should run code. And unlike Java, you could actually write code anywhere in the file, including outside the class. For testing, make sure to have include IOStream, which allows us to use the standard input and output stream objects. Next, in your main method, call the standard namespace. This contains standard objects like character output, which we could use to print things to the console. Using the insertion operator, we can send data to the output stream. And wow, just like that, we've printed Hello World in both languages. As I'm sure you've noticed, syntax for both languages is pretty similar. They both use semicolons and curly brackets, which is common for languages in the C family. But there are many differences. Unlike Java, where strings are a fully fledged class, with many built-in methods like length, substring to uppercase, C++ treats strings in a more low-level way by default. In older C++ code, strings are simply an array of characters, which means you have to manage their size in memory and can't directly call methods on them like in Java. However, if you include the string header, you could use the string type instead. Getting input in both languages is a bit different as well. In Java, you import scanner from the util package, and well, it's Java, so you create a scanner object from it. On this object, you could call these methods, which you could set to a variable or printout or whatever. In C++, as long as IOStream is included, you could write standard character input to read input from the console. Then you could use the extraction operator to set it to a variable. Okay, well, what about classes? Both languages can do it. Java is built for it, and C++ was designed as C with classes, literally starting out as an extension of C to support object-oriented programming. Say we want to make a bank account class that can handle storing balance and withdrawing from the account. In Java, we need to make a new file, public class bank account, then the instance variables, constructor, and other functions. The only thing that we're missing is to make the instance variables private and functions public, like this. Functions in both languages are defined with the return type, function name, and parameters. Back to our main class, we can write bank account, a name, equals new bank account, which creates a new object. This is the backbone of most Java programs because Java is heavily object-oriented. If we wanted to test it out, we could print withdraw, give it a parameter, and there we go. In C++, we don't have to make a new file. Outside of our main class, we can just declare class bank account, and if we want to make something public or private, we just use a flag like this. Anything under this private flag will not be able to be accessed outside the class. So we could put our instance variables here and our methods under the public flag. The rest is the same, besides that you need to end the class with a semicolon. Back in main, we have two options for creating a bank account. We can create a stack allocated object like this, which will be automatically destroyed when it goes out of scope, or we could allocate it to the heap like this, in which case we're responsible for freeing it manually later. Speaking of memory, Java handles memory allocation way differently than in C++. Java has built-in garbage collection. This means that if you create an object and that object becomes unreachable in the code, the garbage collector will eventually free it from memory for you. In C++, you do not have this luxury. If you don't free an object from the heap when you're done with it, you have created something called a memory leak. And over time, this unfreed memory accumulates, leading to a gradual increase in the program's memory usage, which could lead to bad performance or even crashing. A big plus of using C++ is full manual control over pointers, which means you could directly access and modify memory addresses, do pointer arithmetic, and cast between pointer types, just like in C. C++ gives a lot more power and precision, which makes it ideal for high-performance software like real-time rendering or simulation. Java trades some of that control for safety and simplicity, which is why it's used for applications where stability, portability, and ease of maintenance are more important than squeezing out every last bit of performance, like enterprise software, mobile apps, or web services. Remember when I brought up that both of these are compiled languages? That's mostly true. In C++, all code is turned directly into machine code with a compiler. In Java, your code is first compiled into bytecode. That bytecode isn't run directly, instead it's passed into the Java Virtual Machine, or JVM. The JVM then translates it into machine code for whatever system you're on. This makes Java code highly portable. As long as the OS has a Java Virtual Machine installed, it can run any Java program. Hence the famous slogan, write once, run anywhere. Overall, Java focuses on portability and ease of use, handling a lot of lower level stuff like memory management for you. C++ gives you more control and flexibility, but that comes with more responsibility and potential bugs. I know that this was not a deep dive into either of these languages, but if you're used to using one and you're curious on how the other operated, then I hope this helped. Thank you for watching. Have a good day.